When I chatted to Henry later, I said I thought this piece would be somewhat more interesting for everybody. It's a study I completed a year and a half or so ago, along with Mr. Michael Grayling, my supervisor at WITS. And for me, it raises a couple of interesting questions regarding higher education. We talk a lot, as we heard in the keynote, about items such as funding situation, socioeconomic status, the circumstances of our students. What this study refers to more is the intrapersonal factors and the cognitive factors underlying success rates, along with secondary education performance. So it's a little more focused in on the student as an individual, although it obviously then also relates back to all the factors mentioned, okay, as you will see. Sorry, just forgive me, it's a lot of detail in the slides when it gets to the stats, so I need to look back and forth, all right? If you have questions as we go along, then please just feel free to ask quickly at that time, just so if you need it to be clear. Okay, just a brief bit of context. Can I move that? All right, in 2009, approximately 521,430 students were enrolled. Of those, around 16% graduated within 3 years, and about 30% dropped out in the first year for various reasons. Now remember, defining dropout is a little bit complex. It doesn't necessarily mean dropped out academically. What is the buzzing? Okay. It doesn't necessarily mean dropped out academically. It could be students left because they could no longer afford to study. I wonder if it's my phone. Put that there. It could be students left because they could no longer afford to study. It could be that there was parental pressure for them to go and work, so on and so forth. We all know there's a lot of factors at play there. What was identified is a shortage of skills in the labor market, and I'll show you a few of the references at the end. Now, this is important, and this led to a promotion of mass participation in higher education, partially to address the shortage of skills, partially because higher education is a conduit to social and economic advancement. So entry into the global economy, hierarchies within society, certification for careers, and this is particularly true of previously disadvantaged groups in a country that is as diverse as South Africa. So we can see it's a very complex issue. In terms of selection into higher education, generally academic point scores are used, all right, but these are strongly influenced by other factors. We all know this. All right, so APS identifies achievement rather than potential, okay, and it's important for us to differentiate between achievement assessments and between cognitive assessments, as you'll see in a moment, okay? Both have been used to predict educational outcomes quite successfully. It is generally considered incorrect to try and use IQ or cognitive assessments as the primary indicator of tertiary education outcomes, but this does not mean that it's not useful in specific contexts, okay? The issue with this is that cultural experience and various opportunities actually impact how cognitive skills are expressed. Okay, so as we can see, the issue becomes more and more complex as we go along. We all know there's many factors outlining success in tertiary education, all right? Generally, studies have found that intra and extrapersonal factors, as you can see, I've listed some there, account for only around 4% to 6.5% of variance in academic performance in tertiary education. This isn't as much, statistically speaking, as I believe a lot of us observe, if you will. So issues such as finance, bursary status, housing, socioeconomic status, family background, etc., actually between them do not account for a huge amount of variance in tertiary outcomes. So the first question we need to ask ourselves is what accounts for the rest of that variance? One thing I want to draw your attention to is cognitive ability, attention, and working memory have been quite extensively studied. They're shown to be less developed in low socioeconomic children for unknown reasons at present. Those same children tend to have underdeveloped language skills. Some of this is cultivated in early childhood development and some in the schooling system. Okay, so it is influenced quite strongly by the schooling system and by parental upbringing. So just very briefly, cognitive intelligence, a sum total of cognitive processes including planning, information processing, attention arousal, learning potential, metacognitive factors, ability, decision making, and so on. The list really does go on. Psychometrically speaking, intelligence is what intelligence tests measure, okay? A man-made construct, if you will. This is just a quantification of observed behaviors or skills, which we then infer reflect intelligence through correlations with achievement outcomes and other reliable measures. Okay, so it's important to remember that there's a lot of misinformation about things such as intelligence. It's not a finite concept, it's always evolving. There are just some of the issues in selections, all right? What influences what? Where does it all begin? Statistical control over all these variables is probably not possible. I don't think anyone will ever be able to do it. So we do smaller studies such as this to try and isolate specific factors. Right, let me get on to this. The cognitive assessment that we used, or it was actually archival data, is suitable for below grade 12 education levels, okay? And it is tested to be culture fair, or as culture fair as these assessments can be. The areas of intelligence and achievement, conceptualization or the integration of visual information, mental alertness, which is implied differences, calculations was achievement and logic oriented and quite strongly loaded on English language skills. Observance was the implied differences in nonverbal information, so it had no loading on English language skills. Reading comprehension and memory, of course, that is English dependent. Insight was the inferences and manipulations of verbal information, but did not, has not loaded particularly highly onto English language skills. It's not very vocabulary and syntax dependent, that assessment. It's more regarding manipulation. And then object assembling, which is spatial reasoning. When this instrument was first studied in 2002 at that same institution, it counted for about 60 to 90% of variance in academic achievement. That is very high. But if you read the particular research in question, the range of how they defined academic achievement was quite small. So they took, for example, marks in a specific subject in the first test of the term, things like that, okay? The validity coefficients were fairly significant, all right, although practically perhaps not as high as one would like, and the inter-item consistency was at an acceptable level. Right, for this particular study we collected APS and we collected average mark, and now you're probably thinking, how did we put all of this together? It was a bit complicated. Right, we had a sample of over 4,000, all right, per intake, by the way, 2010 and 2011. Now, because we had this problem that some people had written the cognitive assessment but not registered, either because they weren't accepted or whatever, and some people had enrolled but had not written, all right, we had a lot of missing data. So we used Rubin's multiple imputations with 5 iterations. We then conducted the analyses using the pooled result in most cases. Right, so on to the fun stuff. Well, fun for me, I'm not sure about everyone else. All right, just some preliminary analyses. The PIP-speaks demonstrated quite normal levels of skewness and kurtosis. The internal consistency and reliability was at quite acceptable levels, as you can see on the screen. No removals of any of the subscales. Remember, I listed the 7 tests which make up the instrument. Would have assisted in improving the reliability, so no scale was under or over contributing. The APS scores that we had listed ranged from 5 to 77, despite limiting factors we put in place during the multiple imputation process. So those very low APS scores came directly from the institution, the data that they provided us with. Okay, so we don't know whether it was a typo or whether it was in fact correct. Okay, that's impossible for us to find out. APS was quite strongly positively skewed. All right, that means there was a truncation at the left end, so the lower end of the spectrum. In order to address this for our later analyses, we performed a log 10 transformation, which in itself has its own dangers. This distribution was also very strongly leptokurtic. Okay, so it peaked very highly. It was not a nice even spread, if you picture the normal distribution. Average mark, you can see they had a huge range. Also a leptokurtic distribution, generally within the 40 to 60% range. We confirmed that using scatter graphs. Here, the only thing you really need to note about the means between 2010 and 2011 is, for whatever reason, APS, the average, increased. Okay, there could be a lot of reasons behind that. Right, we did find significant demographic differences at the 5% level. We're not sure if this was due to sampling size, random fluctuations, error. The Cohen's d, which is an effect size, as well as the probability of superiority values, were quite low, all right? The ones that were higher were students with NSFAS and bursaries tended to have higher APS scores, and students in residence tended to have higher APS and better average marks, which again speaks to circumstances of the students and how it affects their studies. Inferentially, we used the log 10 APS, all right. Pearson's correlation coefficient, they were all significant with the exception of 1 or 2, but the coefficients of determination were not particularly high. APS was the strongest, but nowhere near as strong as one would expect. I think at the end of the day, it accounted for 5% of variance only. Okay, very poor. Our multiple regression model, the initial model, was significant for both 2010 and 2011. As you can see there, the p-values are very low. We also analyzed the standard regression coefficients. All right, is everyone familiar with those? No? Yes? Shall I explain? Okay. These give us an indication of how many standard deviations a DV will change per standard deviation increase in the IB, okay, the independent variable. So what this allows us to do is essentially compare apples and oranges. We can compare two different units of measure in a much more reliable manner. So those are actually, you will see now, quite important. All right. So first we had a look just at our cognitive testing instruments, all right, exclusive of APS scores. Now I need to explain quickly how we designed our stepwise models, okay? Some of you may be familiar with stepwise models. There's generally two methods. One is to let your stats program input your variables in strongest order. The other is to deliberately enter variables in a specific order. So your strongest variable, the variable you hypothesize has the strongest relationship with your DV, you would input first, and then following that you put in your next strongest, and so on. So in order to discover this order of input, our initial variable was that which evidenced the strongest correlation. We then made a series of 2 variable predictor models and selected those variables which explained the most variance in average mark. Okay, and that is how we got our order of what to impute first. When we did the logistic regression, you remember I mentioned that quite severely leptokurtic distribution. This results in considerable range restriction within the scores. Sometimes it's then more useful to divide your scores into 2 groups, okay? In this case, we did pass and fail. Pass being 50% or over, fail being below 50%, quite simple. And for that, we were also able to increase the range of APS scores that we used as a predictor variable for the simple reason that logistic regression can handle non-normal distributions a lot better. All right, I can see some people look a bit sort of shell-shocked at what's going on here. All right, now on to the very fun stuff. All right, we analyzed 2010 and 2011 intakes separately for various reasons. For our 2010 intake, the variables we used for the speaks only in order of priority were the insight scale, so the manipulation of verbal or written information, the observance scale, spotting the differences and analyzing nonverbal information, and conceptualization, the integration of nonverbal information. So you can see there all our strongest predictors related back to manipulation to analysis of information. They weren't strongly loaded on English language specifically, and they didn't rely heavily. They relied more on learning new skills and applying new skills than they did on previously learned material. Okay, for 2010, this model was significant. It did achieve a significant fit, but only 1.9 of variance was explained. All right? For insight, that explained 1.2% of variance. All right, very significant. The change for observance was then an additional 0.6%, which was also significant. And the change for conceptualization was an additional 0.2%, all right, which was just significant. It just squeaked under the 5% level that we set. However, none of our beta values were significant. Okay, so what we see here is a bit of an incongruence. Things, I wouldn't say they're not quite adding up, but it is a fairly poorly functioning model from that perspective. But it is a significant model. So it's important to differentiate now between what is practically significant and what is statistically significant. What are you actually seeing when you look at these models? For the 2011 intake, okay, it went observance, insight, reading comprehension. So you can see for this intake we had different factors at play. Again, the model was significant, okay, and it explained somewhat more variance than our 2010 model. This may have also been due to the fact that the average mark for the 2011 was purely first year only, okay, whereas the 2010 average marks were taken over that period of study. So I think it was a year and a half, 2 years. Right, so observance, 1.2% of variance with a change then of 0.8% to insight, significant, and to 0.03% for reading comprehension, which was not significant. So we can see there that observance and insight seem to be our best predictors within this instrument. All right, we then conducted the stepwise regression, again inclusive of APS. Obviously, we went through the whole process again of deciding on our variables, okay, as I mentioned previously. So for the 2010 intake, APS, then insight, observance, and conceptualization. This achieved a significant fit and explained only 4.7% of variance. I expected more with APS included. Personally, my supervisor also said, you know, he's not sure. Since APS is what we have been using as the primary indicator for predicting success, essentially, we did expect more variance to be explained. So APS explained 3% of variance, which was significant, an additional 1.1% from insight, and 0.5% from observance, 0.2% from conceptualization, all of which were significant at either the 5 or 1% level. Now, the standardized regression coefficients were only significant for APS in that year of intake. So that clearly indicates to us that although we have significant changes as a result of the introduction of these new variables, in practical terms, we would say only APS is significant. All right. How important it is, that is a different question. For 2011, again, the model achieved a significant fit, all right, and 4.8% of variance was explained. Again, 3% from APS. Now you can see here, interestingly, when we did our two variable multiple regressions, observance came out stronger and then insight. When we included all of these variables, insight had provided a greater change than observance. Okay, but that needs to be interpreted a bit carefully. The reason being, the way stepwise regression works, just quickly, is that it takes away of how much variance is explained. So if your first variable takes, let's say, 10% of your 100% of variance explained, there's 90% remaining that has to be split between the remaining variables. Okay, so things sort of can increase or decrease in importance the more variables you add to your model. In this case, our beta values for APS and observance were both significant at the 1% level. When we conducted the logistic regression, as I mentioned previously, it was to deal with the leptokurtic distribution. For those of you who are not overly familiar with logistic regression in this form, the exponentiation of the beta coefficient, okay, determines likelihood of increase in odds with every 1 point increase in predictor. Because remember, we were using a scale predictor. So for APS, there was a significant model, and putting this in just very practical terms, for every 1 point increase in APS, the likelihood of falling into the pass category increased 8.1%. Right. In 2011, it was 6.3%, which was also significant. When we then conducted the logistic regression using the speaks, what we found there was that for observance, it was a significant model. And now here you see a 15% increase in likelihood to fall into the pass category. Okay, that's now a big difference from where APS was. All right. Insight, an 11.2% increase. In 2011, it got even more impressive. For observance, there was a 22.5% increase in likelihood. And for insight, there was a 10.3% increase. So this really confirmed for us that observance and insight, at least as part of this assessment, do contribute in some way to likelihood of pass versus fail within this particular student population. Now, bearing in mind that cognitive development is context dependent and skills may be released through education and early childhood development, all right, this brings us to a conceptual link, a theoretical link between cognition and educational outcomes, all right? Improved reasoning in study has been shown to be linked to educational outcomes, as have improved metacognitive skills. All right, so thinking about thinking. The question remains, though, is which cognitive skills are important? As you saw in the brief introduction, there is a huge variety linked to the concept of IQ and the concept of cognition. But not necessarily all of these are linked to education. So it's a challenge to identify which cognitive skills, all right, are actually linked to educational outcomes, all right, as differentiated from achievement outcomes such as APS or academics point scores. So from this particular study, our observance and our insight scales, if you narrow it down to the basic skills, drawing conclusions from detailed material, logical reasoning, abstract conceptualization, there was a low reliance on formal English skills. Okay, so vocabulary, syntax, semantics, low reliance there, and a high reliance on the ability to manipulate information and develop a system of rules. Right, that was important in both those assessments. So from this, we can identify some form of learning potential through the ability to process, synthesize, and find solutions. Inference of missing information, attention to detail. Okay, these are all skills we know about in theory, right? But are not formally used in conducting selections for various reasons. And they're not necessarily developed as well as they should be throughout a child's life or a young adult's education system. So the symbol systems, this grasping of new skills, relies on deduction, inference, and reconstruction, rearrangement of information, and interpretation of the consequences of information. I'm sure some lecturers will tell us the student can tell me the work, but they can't apply the work, or they can't adjust the work to fit a circumstance, okay? So between this and our English language considerations, we have some sort of an idea of what is going on here. I think I'm almost out of time. I can see Henry getting jumpy over there. Just in conclusion, quite briefly, firstly, you need to understand multiple imputations are not an ideal method. There is a potential for error. Okay, this is not the best method to analyze your data with. But in this case, it was necessary. The PIB-SPEAKS does contribute to the prediction of average mark. How practically significant that is remains to be discussed. Significance can be impacted by large sample sizes. The larger your sample, the more likely you are to achieve statistical significance. It's important to remember that when thinking about this information. Specific scales or specific skills may be more important than others when predicting academic success. Time limits, they may have played a role. The observance and insight scales, just through inspection, we saw that most of the students finished all the questions, which was not the case for many of the other scales. So it's unknown as to what impact time limits had. We didn't control for English proficiency, so that is also an unknown factor, but it may be an overarching factor given the results that we found. So why did APS not predict as successfully as we hoped? Hypothetically, and following a bit of literature review, I've cited the sort of core studies near the end. You can contact me for a full list. Firstly, rote learning, all right, no longer works as well as it should when you reach tertiary education, or as well as it could rather. The application of skills, metacognitive requirements, and conceptualization requirements. Perhaps these things are missing from our secondary system. Right, so just completely in conclusion, mass participation was useful, it was promoted. We need more skills in our labor market, but perhaps a more comprehensive selection procedure can aid tertiary education in improving their throughput rates. Okay, thank you very much.